Okay, so let's demonstrate both of them. I'll start with B. So I need to figure out property B. Now, we only have one alternative as to a type of proof that we can give of this kind of result. And that's because we only have one way of describing sine and cosine functions, that is geometrically. So we have to give a geometric proof. And to write down a geometric proof, we're going to have to draw a picture. And the first step in the proof really is to replace this variable delta x, which is going to 0, with another name which is suggestive of what we're going to do, which is the letter theta for an angle. Okay, so let's draw a picture of what it is that we're going to do. Now, here's the circle, and here is the origin, and here's some little angle. Well, I'll draw it a little larger so that it's visible. Here's theta, all right? And this is the unit circle. I won't write that down on here, but that's the unit circle. And now sine theta is this vertical distance here. Maybe I'll draw it in a different color so that we can see it all. Okay, so here's this distance. So this distance is sine theta. Okay? Now, almost the only other thing we have to write down in this picture to have it work out is that we have to recognize that when theta is the angle, that's also the arc length of this piece of the circle when measured in radians. So this length here is also arc length theta, that little piece in there. So maybe I'll use a different color for that to indicate it. So there's orange, and that's this little chunk there. Okay? So those are the two pieces. Now, in order to persuade you now that the limit is what it's supposed to be, I'm going to extend the picture just a little bit. I'm going to double it just for my own linguistic sake and so that I can tell you a story, all right, so that you'll remember this. So I'm going to take a theta angle below, and I'll have another copy of sine theta down here. And now the total picture is really like a bow and its bowstring there, all right? So what we have here is a length of 2 sine theta, so maybe I'll write it this way, 2 sine theta. I just doubled it, and here I have underneath 2, whoops, I got it backwards. Sorry about that. Trying to be fancy with the colored chalk, and I have it reversed here. So this is not 2 sine theta. 2 sine theta is the vertical. That's the green. So let's try that again. This is 2 sine theta. All right. And then in the denominator, I have the arc length, which is theta is the first half, and so double it is 2 theta. All right. So if you like, this is the bow, and up here we have the bowstring. All right. And of course, we can cancel the 2's. That's equal to sine theta divided by theta. And so now why does this tend to 1 as theta goes to 0? Well, it's because as the angle theta gets very small, this curved piece looks more and more like a straight one. All right? And if you get very, very close here, the green segment and the orange segment would just merge. They would be practically on top of each other. And they have closer and closer and closer to the same length. So that's why this is true. I guess I'll articulate that by saying that short curves are nearly straight. All right, so that's the the principle that we're using, or short pieces of curves, if you like, are nearly straight. So if you like, this is the principle. So short pieces of curves.